Now let us learn how to find out the areas under simple curves. So on the screen you have a curve which is in fact an ellipse. An ellipse, x squared upon a squared plus y squared upon b squared equal to 1. So on the screen is a picture of a curve, and also you can see the region colored in green. So this region is under the curve. Now our aim is to find out the area of this region colored in green. So in lower classes you have learned how to find out the areas of triangles, rectangles, of circles, and so on. But now we are going one step further. We are finding out the areas under simple curves. So, to find out the area of any region which is under the curve, what we do is we first start with a rectangular strip. Now on the screen you have a rectangular strip which is colored in brown color. So that is the strip I am talking about. Now we start with this rectangular strip. The vertical strip shown on the screen, it is somewhere at the middle of that region which is colored in green. But remember, it should not be always like that. You can put it close to the y-axis. There's no problem with that. Or you can put it to the extreme right of the region which is in green color. That is also correct. And the one which I have shown on the screen is just an example. So alright, on the screen you have a vertical strip. Also remember, sometimes you can do it horizontally. But this time let us discuss only for vertical strips. So to find out the area of the green region, of the region colored in green, what we do is we start by finding out the area of that vertical strip, which looks like a rectangle. So because it looks like a rectangle, we know now that the area of that strip is simply y into dx, length into breadth. So that is the area of the rectangle. But there is one little problem. Because if we look at the top of the strip, we find that at the top, the corners, they are not at right angles, they are not rectangular. So when we say y into dx, of course it is the area of the rectangle, the area of the vertical strip, but it will be just an approximate area. It cannot be the exact area. But if we make dx to be very, very, very small, very, very close to 0, if that breadth of that or that width is very small, then this strip will look like a perfect rectangle. I hope you can imagine in your mind that when you make dx very small, very, very small, and very close to 0, then this vertical strip will look exactly like a rectangle. And when you say y into dx means the area of a perfect rectangle. So here in mathematics, and in this particular section of the chapter, whenever you see dx, remember it is not a very big number. Dx is not a big number. It is a very, 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 very small number. A number which is very, very close to zero, almost zero. So that is the thing which you need to remember. So now we have got the area of the strip. Now how to find out the area of the whole region which is colored in green? The idea is simply by drawing such vertical strips. We draw such vertical strips to the right of it infinitely and to the left of it infinitely. So after we have done that, then adding the areas of those vertical strips from left to right, we sum them up. When we have sum up, then the total will be exactly the area of that region which is colored in green. But there is another problem, because we cannot do it by hands. Though the idea is like that, we are adding or we are summing up the areas of those rectangular strips which we have drawn infinitely. We have covered the region which is colored in green. We have covered infinitely by vertical strips which are in rectangular forms. But we cannot do like that by hand. So, since we cannot do it by hand, we cannot find the exact area under the curve. But due to the advancements of advanced calculus, or calculus I can say, what we can do is we simply use the definite integral. And definite integral, as you know, it is about finding the area under curves. So definite integral is actually about summing up the areas of those infinite number of vertical strips which we have drawn. Now, using definite integrals, we can then easily find out the area of this region which is colored in green, because we know the area of that first rectangular strip, and also we know the limits. In this case, we are doing it with respect to the x-axis. Whenever you see dx means with respect to the x-axis. And y, that y which you see on the screen, you can get from the equation of the ellipse. So y into dx, which we have discussed earlier, and using that with the limit x equal to 0 to x equal to a. So we have got an idea how to find out the area under simple curves in the first quadrant if it is an ellipse. But now, let us go one step more. That is finding out the area which is enclosed by the ellipse. That means summing up the areas of those four quadrants which are under the ellipse. So that means 4 times of the definite integral 0 to a y dx. 4 means 4 times. 4 times of what? 4 times of the areas of the first quadrant. So that means the area enclosed by the ellipse in all the four quadrants. So, as you have learned a minute late and before previously, that the definite integral 0 to a means the area under the curve from 0 to a, and these numbers 0 and a, they are actually along the x-axis because you have dx there. So it means that you are finding out the definite integral, which is with respect to the x-axis. So y dx is also the area of that vertical strip. Now, y into dx is the area of that vertical strip, of that single vertical strip. So when we attach the integral from 0 to a y dx means the area of the green region, or the area of the region colored in green. So definite integral from 0 to a y dx is actually the summing up of all the areas of those vertical strips and denoted by the definite integral from 0 to a y dx. Now, as I have said earlier, y can be found out from the equation of the ellipse, and we have to express y in terms of x because we are doing it with respect to the x-axis, because dx is along the x-axis. So we have to express y in terms of x so that we can carry out the definite integral, and from there on we just have to follow the formula which we have in definite integrals, and the value that we got from there will be the area of the region under the curves, and this time it is the area enclosed by the ellipse in all the four quadrants. So that is about the area under simple curves. So I hope with this explanation you have learned a lot and you can carry out many more calculations on your own. So spend more time in practicing.